Okay, students, here we are having the liquid dielectrical materials and the liquid dielectrical materials. Okay, so how breakdowns occur? Okay, that we are going to study now. So here, liquid dielectrical materials are mainly spreading through the high voltage cables. So mainly we are using the that is in the as a cooling purpose as well as insulation purpose we are using. So here, if you using the mainly that is we are in the high voltage engineering, so we are using for the cables. Okay, in the cables as a dielectrical medium we are using as a liquid, and the capacitors also we are using as a dielectrical medium as a uh, oil. Okay, that is nothing but liquid. And for filling the transformer for cooling as well as insulating medium we are using as a liquid. And circuit breaker, so for bulk oil circuit breaker, minimum oil circuit breaker, mainly we are using the that is oils. Okay, and difference also, but all are comes to the and the liquid state. So here and the liquid dielectric mainly used is that is the in type of high voltage cables, capacitors, and filling of transformer for cooling and insulating medium, and the circuit breaker, so as a insulating medium and the in between the two electrodes. Okay, that we are going to. And apart from that, here we are using the dielectrical. Okay, so function of the dielectrical is that liquid dielectrical have additional function, that is a certain application for liquid heat transfer agents that cooling purpose. Okay, not only for the as act as a insulation purpose, that is also act as a cooling agent in the transformer. And mostly not only in the liquids, so having another in the liquids dielectrical medium we are having the petroleum oils are mostly used for the liquid dielectrical. So the petroleum oils are mostly used for liquid dielectrical, so for applicable. Okay, so in that one, so here synthetical synthetic hydrocarbons. Okay, halogen hydrocarbons for heavy temperature application. Okay, in that, so here we are using the different in that one hydrocarbon hydro halogenated hydrocarbons, and it will be used for, okay, that will be used for high temperature applications. And silicon oil and hydrocarbons mainly used for high application. Okay, that is the high voltage applications mainly. So not only high voltage, so it will be whenever the high temperatures are taken. Okay, so some of the dielectrical materials are used. Okay, in that one we have the synthetic hydrocarbon and how for high temperature application. So here vegetable oils also use some of the used. Okay, in some case the not okay. And the liquid dielectricals, so used liquid dielectricals normal is a mixture of hydrocarbons and weakly porous. So if you consider the liquid dielectrics, most of the that it will mixture of the hydrocarbons and weakly it is polarized. And whenever they use for electric, if you use the, they should be in the free from moisture and product of oxidation. Okay, so it should be avoid for oxidation and other recount. So it should be and the free from If it is moisture occurred, so the dielectric strength of the material also decrease. Okay, so whenever using as a liquid material as a direct milk, so we should take that, it should be free from moisture and oxidation and other content, so that will should be clean, so that not contain any other material. So most important factor that electrical strength. So whatever the strength of the dielectric is that, so it is because of the how much water presence is concerned. Okay, so if it is water presence in the dielectrical material, okay, the breakdown strength of the dielectrical uh, liquid dielectrical, it will be reduced. That water particles in this liquid dielectrical, okay, that we have to should take it. And okay, students, if I sharing in the Google Classroom, okay, so you can see in the Google Classroom today material. Okay, some error showing. Okay, now, so I have shared the Google Classroom. Now you can see in the notes. Okay, so what I'm going to teach now, and here, so here most of the factors. So electrical strength of the insulating ions. Okay, so what at what factor it will be affect that. So electrical strength of insulating oils is presence of water in the form of droplets in the suspended oil. Okay, so here mainly water contamination in the dielectrical medium, okay, that will main effect on this, that insulating strength. So here electrical strength, if considering the oil, okay, if considering the transformer, so if it is water contaminated is present in this transformer, so what will happen, so it will be get short circuit. Okay, the insulating medium, whatever the insulating medium we use as a liquid, so the breakdown strength it will be reduces. Okay, so we have to avoid that, whatever the moisture content is there, okay, that should be avoided. Okay, now here if we consider, so if we the presence of water, that is 0.01% is water in the transformer, so it will reduces the electrical strength of 20%. Okay, so if it the if transformer consisting the 0.01 percentage of water, okay, so it will reduces the electrical strength to 20%. So if it is 0.01% if water contamination is take place in the transformer, so that will be reduce the electrical strength, that is the 20% of the dry oil well. So that should be we have take care, so it will there is no water contamination in this transformer. Okay, now consider to the dielectrician. So here the dielectrician of ion reduces the more sharply. So it contains impurities. Okay, so there is no impurities will be there. Okay, so there is no addition in this water. Okay. So the important factors properties of the liquid dielectrical materials are, that is, electrical conductivity, dielectrical constant, and dielectrical strength. So these are three properties should we have for this, the mainly for liquid dielectrical material whenever using the electrical purpose. Okay, that should be having the electrical conductivity, dielectrical constant, and dielectrical strength. So this is the main properties of the liquid dielectrical material. Not only the three colors, so we have another also, that is such as viscosity, thermal stability, specific gravity. Also we have been taking the, so we having these are the main things. So we having the another physical and chemical properties, that is viscosity, thermal stability, specific gravity. So these also another factors. Okay, mainly we are considering that. So electrical conductivity, dielectrical constant, and dielectrical strength. Okay. Here, and some of the examples are having the breakdown strength of the oil. So we have the breakdown strength of the, okay, so if you are considering, so examples, so breakdown strength at 20 degrees centigrade, okay, it will having the 2.5 mm standard spear gaps. Okay, so if you have the breakdown strength of the at 20 degrees, so that distance is that 2.5 mm. So at the spare gas you having the, as we are giving the 15 kilovolts per mm. Okay, 15 kilovolts per mm for transformer. Okay, if you consider that is the, if you consider the transformer, that is 15 kV per mm. And so the 30 kV per mm for cable. Okay, so if we considering the cable oil, so having different types of coils. So in that, if we take the cable oils, that is having 30 kV per mm. Now if we consider capacitor oil, that is a 20 kV per mm. And now we coming to the 20 to 25 kV per mm. Okay, that is ascaral. So this ascaral also is one of the type of the oil. So mainly it will be used in the transformers. Okay, in this one. And 30 to 40 kV mm for silicon. So we have the cable oils. Okay, we have different types of cable oil, we have the capacitor oil. Okay, in the silicon. So if it so if the breakdown strength of at 20 degrees centigrade, if you having the two spare gap, you having the 2.5 mm gap. Okay, at the strength. So if we test that, okay, the breakdown strength, so for transformer oil you're having the 15 kV per mm, and 30 kV per mm for cable oil, 20 kV mm per capacitor oil, 20 to 25 kV mm per ascar oil. Okay, for silicon oil, that is considered, so that is a 30 to 40 kV per mm. So if you consider the in practice, so liquid dielectricals for given application mainly on the base of the chemical strength. So if a practical what we were using, so mainly that is based on the, so if you are using as a dielectrical medium, that is mainly parts of the chemical stability. Okay, and some of the consideration. Okay, environmental influence also concerned, or not only chemical properties. So based upon the stage, how it is appeared, and what are the cooling strength. Okay, that is also considered. Now if you consider the in the capacitors, replacement of capacitor I by ascarel, spreading it to the overall size of the capacitor by 30%. Okay, so here what we are doing, so if you considering the one of the example that in the capacitor oil. Okay, so if you have the capacitor, so some of the capacitor having the capacitor. Okay, so oil also contamination in the dielectrical medium. So in that one, if we remove the capacitor oil, if you replace by the ascaryl oil, so what will happen at that time, so the overall size of the capacitor by more than the 30%. So what are the capacitors? So if you remove the oil, if you increase, you replace the with the ascaryl oil, so it will overall size of the capacitor, it will be increased the 30%. Okay, so here what I have to, so whatever the properties are there, so mainly we have to consider that. So it will having the certain applications only, okay, where should be take, so whatever the properties are there and how it will be taken. Okay, we have to use for certain applications, for certain oils only. Okay, for cooling purpose we are using. So in the transformer oil we having cooling purpose as well as insulation purpose. Okay, so if you consider the, where there are two types of the oils, okay, here liquids, okay, liquids, that is the pure liquids and commercial liquids. So here what are the pure liquids or what are the commercial liquids, let me see. So in the pure liquids are those who chemically pure, okay, pure liquids are those who is chemically pure and does not contain any other impurity. Okay, it does not contain any other impurity even in the traces of 1 in 10 to the power of 9. Okay, it's 1 in 10 to the power of 9. So it is structurally simple. Okay, should be structurally simple. So here pure liquids are those which chemically pure, okay, does not contain other impurity. These are the here examples are that N-hexagon C6H14 and N-heptane C7H16. Okay, other profane hydrocarbon. Okay, so they're having the examples of the pure liquids, that is N-hexane C6, C6H14, N-heptane C7H16, and paraffin hydrocarbons of the examples of the pure liquids. Now considering the here commercial liquids. So commercial liquids is having the liquids like oils. Okay, so commercial liquids nothing but which have insulating in liquids like oils and not chemically pure. Okay, so commercial is that, so it is chemically not pure but normally consists of mixture of complex organic molecules, okay, which cannot be easily specified or reproduced in the series of experiments. So commercial liquid which have nothing but is ice, okay, but is a complex organic molecule. Okay, so complex organ which you consider, that is a commercial oil. So these are the two types of the liquids, that is pure liquids, so which can which chemically pure, okay, does not contain any other material, and which are the commercial liquids, it is a consisting of mixture of complex organic molecules. Okay, these are the two types. Okay, now here purification process of this oil is there.